How's the weather in Philippines?
Still the same. At least it's not raining today, so fine weather and all good. How's your weather as well on your end?
It's great, great. Okay, so it's in India. It's like for my place, it's like it's been really great. Yesterday was raining and all, but today seems to be having a really great weather. So yeah, so I think let's get started. So welcome again all to the session on stepping up your career in DevOps engineering. We have Nicole Kelly from Philippines today with us to be walking us through how you can get started with DevOps. And she is a DevOps engineer, and she will be walking us through all the topics that we have mentioned in the agenda. And let us hear from her.
Thank you again. All right. Thank you, Siraj, for this opportunity and for the warm welcome for my presentation. So I'll just share my screen. Wait a minute. Sarag, sorry, my computer wasn't able to let me to share the presentation. I don't know what's happened. Please share
Oh,
it for me. I'll just share the link on the.
that.
Can you access it?
Yes, yes, yes. Let me just
Okay. All right. Thank
uh,
you so much.
get that for you. Mm,
Sorry for the technical issues.
no, no worries, no worries. It happens.
Oh, okay.
Yes.
All right. Um, So on the first slide, so again, I'm Kelly. I'm a DevOps engineer at IDEMIA, and I was assigned to an international team where I work usually with a European team, and we do like support a lot of users globally. So here are the first things that we will be discussing for today's tech talk. So first is DevOps Fundamentals. We'll be covering about what is DevOps and its definition, how tech companies apply DevOps engineering examples and scenarios, understanding and explaining basics, DevOps concepts, DevOps engineering pillars, and automation. And DevOps Roadmap. Second is DevOps Roadmap. So we will be tackling more about what you can get started to learn, tech stack use in the industry, your learning preference about these technologies, sharing what I learned first, and keep on learning on. Some tips on the tech stack I have used in the industry and what are companies' preferred tech stack, may it be startups or, or multinational companies, and free online learning platforms that help me a lot on becoming a DevOps engineer, on how I gain more knowledge from it and how am I applying it in the industry, and then DevOps in-demand skills in 2022. So these are the skills that you need to be a must-have skills to have before applying or getting into a path of DevOps. So this is really important because I'll be discussing like uh, most key skills and summarize it in a way that you'll be able to like learn it uh, with yourself and such. Then DevOps certification for roadmap. So I know that most of us are getting bombarded with whether we'll be taking these types of certification in a few months, or it is really good to just take the fundamentals from the start. So we'll be tackling all of those. Next, please. Next slide, please. All right. So on this one, DevOps fundamentals are right from the start, as you can see on the slide. Right from the start, software development comprises two different departments. So there is development team, and that develops the plan and builds the system from scratch, and the operations team for testing and implementation of whatever is developed. So the operations team gave the development team feedback that needed fixing and any rework required. So the development team would be idle awaiting feedback from the operations team. So what will happen with this? Like, this side of dev and ops. Next slide, please. So this will actually happen. So this can actually delay the software development cycle. So next slide. So with this presentation, there would be instances where the development moves on to the next project, while the operations team continues to provide feedback for the previous code. So this means errors or even months for the project to be closed and final code to be developed. So what if, next slide please, what if the development team and operations team come hand in hand and work together? It became one. Like they work in collaboration. And what if we break the wall of confusion? So now this is called the DevOps approach. So as you can see, the DevOps symbol resembles an infinity sign, suggesting that it is a continuous process of improving efficiency and constant activity. So now that we'll have a DevOps, next slide, please. So in this slide, DevOps approach makes companies adapt faster, adopt faster updates and development changes. The teams can now deliver quickly and the deployments are more consistent and smooth. Though there may be communication challenges, DevOps manages a streamlined flow between the teams and make the software development process successful. Next slide, please. So on the next slide, as you can see here, is that first in DevOps culture is implemented in several phases. Let us first tackle the plan phase or the planning phase. This is where the development team puts down the plan, keeping in mind the application objectives that is to be delivered to the customer. Excuse me. So once the plan is made, the coding begins. So once the plan is made, the coding begins. Like onto the next step on the slide. So the code begins. The development team works on the same code and different versions of the code that are stored in a repository. So code management tools like Bitbucket, like Git, a version control, like we're gonna tackle it later on. GitLab, GitHub. So that this is where the developers like collaborate all the codes, track changes using Git. So with the help of tools like this one, like Git, like what I mentioned, and merge when required, this process is called version control. So the code is made executable in the build stage tools such as Maven and Gradle. So after plan, code, and then we go to the build. So in the build, there are some common tools that we use. We have Maven and Gradle. So after code is successfully built, it is then tested. So now we go to the testing page in the Infinity side. Uh, After it is successfully built, it is then tested for any bugs or errors that most popular tool that most of the DevOps engineers are using are Selenium. So once the code has passed several manual and automated tests, we can say that it is ready to deployment and can be sent to the operations team. So now what the operations team will do is now to deploy the code. So we'll go through that from the testing side of Infinity, then we go to the deploy. So once the ops team can now deploy the code in the working environment, most common tools used to automate these phases or what I really use is mostly Docker and Kubernetes. And of course, Ansible. So it is the common tools that is used for this one. Then after the deployment, it is continuously monitored. Um, then it is continuously to monitor. Then Zabbix, Grafana, Nagios are one of the monitoring tools that uh, are really common. So on what I have used in the past. So the feedback received after this phase is sent back to the planning phase, and this is what forms the core of the DevOps cycle. Uh, the 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 Jenkins part or the integration part phase. What most commonly used is Jenkins. So it is a tool that sends the code for building and testing. If the code passes test, it is sent for deployment, and this is referred to as continuous integration. So this is how it works. It works like a cycle. So it's a software development cycle of the pure DevOps. So next slide, please. So giving by definition, DevOps engineering by Wikipedia it aims to shorten the system's development cycle and provide continuous delivery with high software quality. So in real life, DevOps is many companies would want a DevOps engineer that can actually code, build, test, deploy, and monitor applications. Next slide, please. Okay, so I have here three DevOps engineering pillars. So the three pillars of DevOps are pull request automation, deployment automation, and we'll be understanding those one by one later on. But the idea is pull request automation helps developers build things faster and helps them understand whether the proposed change is good and the proposed change is good, and deployment automation helps you deploy your code in a way that users don't complain. So, for example, like big tech giants like Facebook, Netflix, Instagram has lots of deployments. It has a lot of deployment automation because if they just threw their code out in the void every time the developer made a change, there would be hundreds of millions of complaints. And application performance management, which is in the last pillar, is automation around making sure that things are healthy. So automatically detecting downtime, automatically waking someone up, the site goes down or overnight, automatically rolling back if there is a problem. Next slide, please. So on the next slide, I'll be discussing the first pillar of DevOps engineering. It is the pull request automation. So pull request automation, it has primarily to do with the developer feedback cycle. So developers share work with each other by proposing atomic sets of changes called pull requests. And by atomic, it means they are full featured on their own and don't require other things to run. So if a developer proposes a PR, they should be expecting that the change is good, and as far as they can tell, the change fulfills some business requirements. And then what they have to do is get through some gates. So organizations, pull request automations, their goal is to make sure that the developers can tell very quickly whether their change is good or not. So, for example, if you're working in a website or with a dockerization of a server, deployment, and such, and the developer proposes a change that adds a typo. It's something that can be easily detected. And if you set up a type gate that says no change, may go in it in it if it contains a typo. So that would be an easy way to make sure the developers get automatic feedback about the changes. Next slide, please. Okay. Well, I'd like to add the so most in a recent year, 2022. So most of the developers are calling it like a Git. So actually, a Git is really helpful and has been like um, part of our daily work and routine as a developer, DevOps, and such. And may it be and it may be a whatever position in the tech industry. So Git is a technology originally popularized by Linux. So it helps developers make the source of changes and share share them with each other. So a pull request is usually reviewed by at least one other programmer and something called code review. Next slide, please. Okay, so this is something called a code review. So in code review, this is where other programmers will tell you about code style and will tell the proposing programmer whether there's architectural problems, scaling problems, or subjective things that can be easily automated. But that process of review can also be greatly facilitated by DevOps tech stack. So DevOps automation can help things like ephemeral environments and from linting and from all these other automations. So usually, as I've stated in the presentation, usually an engineering manager or product manager in charge of the functionality being proposed will get feedback. So if you create a new button on a website, you like the designer that design a button, and you'd like the product manager that requested the change, or the button to be created. So both give feedback, because if the button is praised poorly, if it's placed poorly, if it's not mobile responsive, those are all problems that would require another merge request. So it would be really great if um, all the business requirements are actually fulfilled on the first pull request and it's being merged for the first time. So it would be a less hassle to the workload. So well, usually non-technical people will give feedback on pull requests as necessary. Next slide, please. And on the next slide, so what can be automated? So continuous integration for change. So you can automate things like automated test running for change. So ephemeral requirements, automated security scanning, notification to reviewers, getting the right people to review it at certain times. So the end goal of this automation is that a developer should be able to propose a change and get it merged the same day they propose the change. So that's a huge organizational benefit. So it means that critical bugs can be very quickly fixed and merged and deployed without needing a special process. And it also means that developers are bogged down in bureaucracy. So they can't propose changes once they get through all the gates. So the change will be deployed. There isn't additional gates that they need to discover. So, for example, if the proper gates and automations have been set up, a developer should be able to change a web page without having to ask everyone in the company. So whether this web page is used in certain workflows or not, by virtue of passing the test and passing the QA review, it's assumed that the new change is good. And if a problem does arise, a new gate can be added to the automation so that in the future problems, it won't occur. Next slide, please. Okay, now we're here on the second pillar. So second pillar is deployment automation. So in 2000, Stack Overflow founders posted a question that can you make or build in one step? So as the second most important question for a development organization. And things haven't really changed since then. So the efficiency of the build process isn't the only goal of the deployment automation. However, other goals include the deployment strategies, just like canary deployments, where you want to show a feature to one user at a time, starting new versions of your application without causing any problems or downtime. If you want to shut off your website before upgrading it and then turning on the new version, the visitors that visit the website in the middle of the upgrade will not have downtime. So there's clever deployment strategies you can do to avoid that. And finally, rolling back in case something goes wrong, it's easy to overcomplicate. Many companies have complex internal platforms for building and distributing this. Next slide. Okay. So a goal as a DevOps engineer is that broadly success and deployment automation is finding the appropriate tool to fulfill business goals and configuring them. So you always find the right tool for it. It's not because you know this tool, okay, it's necessary, it's much more faster to do with it, but it's not efficient. So you always weigh in what are the right tools to use. May it be on the efficiency side or the a much faster side. So you can actually weigh those tools on choosing when it comes to strategizing your DevOps engineering application in real life. Next slide, please. Finally, um, finally, we have on our last pillar, which is application performance management. So now I've just stated the keywords on the metrics. So first, even the best code can be hamstrung by operational errors. So there's a famous case where a user put a bunch of spaces at the end of their post in Stack Overflow, and they brought down Stack Overflow, which is a very popular developer site. So because Stack Overflow hadn't deployed their code in a way that would deal well with a bunch of white space. So bunch of space characters at the end of a post, even with the best code. So and even with the simplest things like a messaging board, it's easy to have faults that make it production and are only uncovered by users. So application performance management ensures that metrics like how long it's taking a request to be processed, how many servers are being used, and all of those key metrics are, are processed. So second is logging. So as the program executes, it will produce logs. And the logs generally have information about the state of things. It's useful to be able to map backlogs, like a user visited the website with information about the user. So what was their IP address, username, resource did they access, and what resources were used for fulfilling the access. So if they had to load something from a database and the database was slow, it's useful to be able to say the user had a slow experience because the request was fulfilled slowly, but the request was fulfilled slowly because it was fulfilled from the database. Third one is monitoring. So as mentioned in the metrics, um, this will automatically alerting people, but taking the logs and metrics. So how slow are things, how much memory is left, and deciding what to do. So if there's a bunch of load, you might decide based on the metrics to automatically scale the number of servers. So add more web server as they are being used. Lastly, alerting. So alerting is when fault is detected. So some trigger has occurred based on the metrics, some number of requests, or to slow things are unhealthy. Users are going to notice degraded performance. Someone should be notified, or something should be done some action. So that's the whole thing about application performance management. Next slide, please. Okay, so here we have some. I've actually explained how large tech companies, enterprises uses DevOps and how they apply with it. But let's say we have here an example, a scenario, a startup with no users and building a web application. So at least recommended free tech stack for this is, of course, on how they would like manage their code and open for free because they're just starting. It's GitHub, then Netlify or Layer CI. So most of the examples that I gave or stated in the presentations are usually like applied in a much bigger tech companies. But I wanted to like at least try to explain here the example of what if there's no users, there are no complaints uh, to be getting to get or uh, like a company from scratch. So how will they apply DevOps to this? So this is at least a first example to show. Next slide, please. Okay, So now we're here in a slide on how DevOps is applied in big companies. So DevOps was applied in large tech companies. Like almost all companies has DevOps. So Netflix use it, Spotify, Google, Facebook, and such, Amazon. Next slide, please. So in 2007, Netflix was released, but in the year 2014, Netflix downtime for 1 hour, it cost them $200,000. And now Netflix just embraced the DevOps. Next slide, please. So imagine the amount of dollars that they've been wasting for a 1 hour of downtime. That's just 1 hour, and it results for them to lose a $200,000. So in this uh, slide, Netflix opted with DevOps, and so Netflix developed a tool called the Simian Army that continuously created bugs in the environment without affecting users. So this chaos motivated the developers to build a system that does not fall apart when anything happens. So now Netflix is using DevOps well and apply DevOps engineer well in their company, and now it saves them a lot of time and money and satisfy most of their users by using. Okay, next slide, please. Okay, so now we're here on okay. First slide for the DevOps Roadmap. So this well, actually, just a quick storytelling. I started from a data science background for a year and 4 months, and I was able for at least less than a year. I was able to get an opportunity to be a data engineer, majoring in Azure, Microsoft Azure, and a Google Cloud Platform data engineer. So both cloud computing from tech giants. I've used it from my past projects. And here's what I have compiled for you to be able to uh, have at least a knowledge on what you would what you would need to learn before you start DevOps, or is your knowledge or enough how important it is to learn before getting into DevOps path. First is programming languages. In real life, in my professional experience, what so I put a legend on this one, so it's highly important, normal. But this is just for me, my own preference. So if you guys have your own preference, whether you want JavaScript as your own language and you want to mark it as highly important, that is okay. If you have the copy of the presentation, you can like edit it for yourself and keep it as copy and just change the legend that you prefer or change the colors of it so that you'll have at least a guide. So in real life, what I have an experience is just Python and JavaScript. I mean, I haven't learned Golang and Ruby, but just Python and JavaScript because I've been using Python, JavaScript for a lot of years. So, but I can say Python is really good for scripting. So this is the most in demand. Server administration, I've used Linux and Windows in my professional life. So that's what I have experienced. This is really important. Why? Because most of the companies, may it be startups or multinational companies, they want you to learn Linux and they want you to know at least the very basic or fundamentals of it until you get into intermediate and advanced stage. Because why? You'll get into a lot of servers. You're going to log in with a lot of servers. You're going to like change and edit and remove anything with the use of Linux. So Windows, I've used it in like PowerShell scripting and such, but mostly it's Linux. So it's highly important for me. Network and security. So of course, I have experience for both. So TCP and IP, like for port mapping, especially when I am developing for a Docker image and such. Virtual machines, so it's very important to use if you are dealing with ephemeral slaves, virtual machines, Windows slaves, and such. You need to know at least the TCP/IP fundamental because it will be dealing with a lot of IP addresses and such, the connection flows, the open connections or not, whether it is hosted in your country, like example in Manila or in France or in Indonesia. So you need to know a lot of these network and security. And protocols, DNS, HTTP, of course. SSL, I've been renewing a lot of SSL certificates for every servers before it expires. So it's important for me. Next slide, please. Okay, servers. I mean, guys, you don't need to learn all of these, but at least just learn what technology or tech stack you're comfortable with. If I would recommend something that you're not comfortable with, or I don't like to learn this tech stack first, I'm much more comfortable than go with it because you're comfortable with it. It's just that if you're comfortable with it, you're going to excel much more with that tech stack. Like I myself, I don't really know how to do Golang or Ruby. I'm much more comfortable with Python because it's easy to learn from my preference, and so I choose Python as like my main language to major. So let's go on with the servers. Web server, I only have experience with Apache, Nginx, and Tomcat. Caching, I still don't have experience with this, but I'm still learning, so I've highlighted it as Redis as highly important because it's the most common that I've encountered before, but I myself don't have experience. Still learning. Databases. So in my professional life, what I have experience is MongoDB and Google Data Store. So only two. And SQL, I have experience with Postgre, MS SQL, and MySQL or MariaDB. So I have three of the tech stack here in the SQL part. So next slide, please. So infrastructure as a code, this is really important because infrastructure as a code is usually tackled in a fundamental certification, AZ900, um, Google Cloud Digital Leader. So this is really like the highlight, everything. So infrastructure as a code, you need to know all of these stuff, especially the a much more deep dive explanation. But under the infrastructure as a code on the roadmap is that first, configuration management. In configuration management, I only have experience in Ansible in my professional career. In container, under the container, I only have experience with Docker. Container orchestrators, only Kubernetes and Docker Swarm. But as a beginner, infrastructure provision, I only have one, which is Terraform. So, and next slide, please. Okay, so for this one, CI/CD, continuous integration and continuous development. First one under this, I only have experience with Jenkins and Google Cloud Build plus Bitbucket pipeline. So I only have three of experience using of these tools up until now, working as a DevOps engineer. So I use this every day. Though for my daily in my current, I mostly use is Jenkins. So it's really the main phase for the integration part, sends for the full cycle. Next slide, please. Next slide, please. Next slide, please. Okay, thank you. Okay, so where I in my whole professional career, guys, I'd like you to share that I haven't been into any bootcamp. So from shifting to data science, data engineer, cloud to DevOps, I've been using these online learning resources in YouTube channels only. And I've learned from these a lot. So first is DevOps Directive, Free Code Camp, Network Chalk, automation step by step. So in DevOps Directive, he tackles a lot of open source projects, interviews, Kubernetes, database, networking, security, monitoring, deployments, cloud providers, career advancement. In Free Code Camp, it's the basic stuff. It's more of the fundamentals, theories, and culture of DevOps engineering. It's prerequisites. Network Chalk, this is in a more of intermediate level and beginner to intermediate. It is where I've learned how to Dockerize, Docker compose, and such. Python language as well. Automation step by step. It's more of a Docker Swarm. This is where I learned Docker and Docker Swarm. And ITK Fund. This is where I learned a lot about Azure and Google Cloud Computing and such. More on cloud providers about DevOps, data engineering, and simply learn. So next slide, please. Next slide, please. Next slide, please. Uh, Next slide. Okay, thank you. Okay, so what next? So you're making the most out of the internet and take advantage of the tools available. So that's what I did before I became a DevOps. So first, high demand skills in DevOps is Linux fundamentals and scripting. So um, most preferred language is Python. So what are those days when companies worried about proprietary operating systems? We are now in the era of Linux. So most companies prefer hosting their applications on Linux. As such, skills in handling a Linux operating system and are very crucial for a DevOps engineer. So a DevOps engineer must be able to handle any scripting language and must be well versed with at least one scripting language, preferably Python. So the inevitable DevOps skill set would be Linux and Linux-based scripting. So on second, it is the knowledge on various DevOps tools and technologies. Um, under under these DevOps tools and technologies, so DevOps practices are executed in various stages. So I'll explain each stage. It has tools and can facilitate that stage. The main stages are first, source code management. So here in source code management, developers create and modify the software codes regularly, and source code management software is used to store the code, merge new code to the old one, control the code versions, etc. Next is configuration management. In configuration management, it is used to keep track of software and operating system configurations. It also helps to manage configurations across thousands of servers. It is done through a click of a button or the execution of a single command on the management server. So the configuration management tools take a remote connection to the target servers and push the configuration changes, making life easy and simple. So Puppet, Chef, and Ansible are the top layers for configuration management. So next is what we have is continuous integration. So continuous integration, abbreviated as CI, is the process of automating the code integrations from different developers. And next is continuous testing. So continuous testing is the process of reducing feedback, waiting time after code testing. The code is tested in the development environment itself. So using automation testing tools like Selenium, Test Complete, Testing Wiz are the most common tools for continuous integration. And next is continuous monitoring. So continuous monitoring is used to monitor application performance, downtimes, error logs, etc. The main tools are Nagios, Zabbix, Splunk, Grafana, etc. And lastly, of that stages is containerization. So it is the process of virtualizing an operating system so that different containers running different applications can share the operating system and system resources. So this is opposed to the traditional way of hardware virtualization, wherein the system hardware is shared among different virtual machines like Docker, Kubernetes, and Vagrant are the top providers of containerization. So I've used Docker a lot in my in my workload to containerize a server and such, and modify a base image and attach it to Jenkins, and so that the developers can test and get results from what they're testing on their app. And then continuous integration and continuous delivery. So continuous integration and continuous delivery are abbreviated as CI/CD. It is the essence of DevOps. So it is the practice of continuously integrating all the code from different developers, continuously testing them and deploying the successful code to production. So deploying to production will mostly require spinning up new containers, which is again automated using scripts. Next slide, please. Okay, so now we have here key concepts of DevOps. DevOps, unlike what people I think, is neither a technology nor a tool. So it's a methodology that doesn't have a strict framework. So companies can adapt the methodology by tailoring the framework as per their standards. So the DevOps methodology's main target is to bring the development and operations team together to reduce the gap together um, between them. So it's to reduce the gap between dev and ops so that work is performed faster. So using DevOps methodology, companies are able to deliver quality software much faster. So next is soft skills. Um, in my whole professional career, soft skills are highly important because you'll be meeting a lot of people, you'll be presenting to a lot of people, you'll be presenting solutions, you'll be asking with your colleagues, you'll be connecting with different teams globally or within your team to communicate the problem, to provide solution to their problem, and it plays a great role in the IT industry. With the adoption of DevOps methodology, most companies prefer an agile way of working using DevOps methodology so that teams work in high velocity and produce deliverable faster to meet client expectations. So soft skills are ever more required when working in DevOps world. And lastly, what we have here is infrastructure as a code. So previously, provisioning IT infrastructure was a long, tedious, and manual process. With the birth of cloud computing and containerization technologies, the infrastructure needed by developers can be provisioned, though through an automated script. So the script executes the required commands and does the configuration management using one of the configuration management tools. The required application, platform, or infrastructure is delivered in seconds. And next slide, please. Okay, so this is the DevOps certification for Roadmap. So I believe all of the participants are gonna have a copy with it. So on my last slide, I put references to make this presentation, slides, and all of the infos simplified and summarized by me as well, and put all of my knowledge, experience uh, that I've experienced in my professional career. So you'll be able to get those information a lot if you want to deep dive more into it. So this is DevOps certifications for Roadmap. So next slide, please. Okay, first we have Azure Roadmap. So back then, when I was starting out as a DevOps, and up until now, I've been really thinking a lot whether what cloud computing platform I should choose. Well, actually, it's part of the roadmap as well. I'm not sure if that slide have been skipped, but just to add, this the cloud computing platforms is part of the um, DevOps roadmap. So may it be you will learn AWS, Azure, GCP, Atlassian. So, but in my whole experience, I have learned uh, two cloud computing platforms. It is GCP and Azure. And from what I've experienced, um, a lot of companies are preferring AWS or Azure. So most of it, I mean, um, when they want or try to recruit someone, a DevOps talent, most of the skills they are requiring are very fluent in AWS or Azure. But I just saw some companies like preferring GCP, but because I've used GCP for a lot of years. So here's an Azure. So just like to add that up because I think it just skipped the slide. So in Azure roadmap, it's certification roadmap. So all of us things that it bombards us a lot whether we go to the mid side of exam or not to take fundamentals anymore, but it's actually highly recommended to take the fundamentals exam. It's for us to have a confidence taking the examinations once we pass it, because fundamentals for me are really important. And before we go to a DevOps engineer expert, it has a prerequisite as well. So you would need to take a DevOps a fundamentals exam first before you go to expert. Next is so this is for GCP for the people who would want to focus on GCP. Well, I've had a lot of colleagues and friends and people on the internet asking me what cloud computing platform should they use. So it will always depend on your preference. First, if your preference is that this cloud computing platform is much more suitable for me, or much more easy for me to understand, and I'm comfortable with their technology, you can go with it. But as for my experience, I have chosen cloud computing platform that I wanted to major, but I get some, some companies uh doesn't require that technology or computing platform that much. So they prefer other cloud computing platform that I do not major. So it depends on you guys on how you would like weigh in, whether it's the comfortability or second one, if the companies are preferring this cloud computing platform much more. So it's up to you to decide. So okay, so here's the GCP roadmap. So cloud digital leader, it's a foundational associate. Once you pass all of these two exams, you can have into whether to the professional side, whether you want to be a cloud architect or quickly you can just go on to the cloud DevOps engineer. So next slide, please. Okay. This is the AWS certification roadmap. So first you'll start as in fundamentals. So I'll let you see this one so that everyone can take note of it. So next slide, please. Okay, so there aside from cloud computing platform, guys, there are a lot of there are actually a lot of native certifications roadmap to this one. So there's Linux certified if you want, CompTIA for network, Red Hat, so CCNA. So uh, hope these certifications could be really helpful for you if you wanted to take exams and Kubernetes and such. So there's actually a Docker certification as well because I've researched on the internet that there's a certain certification for Docker. So if you would like to add that up to your credentials, it would be good. But I do recommend, aside from reviewing certifications, guys, I would like to recommend to you that you at least practice a real life project rather than sorry, aside from reviewing theoretical stuff so that you would be able to understand those things because certifications um it's good, yes, it's highly good, but if you don't know how to apply it in real life then it would come to waste. I mean, you should at least, if you have certification, practice on your own personal projects. Next slide, please. And lastly, the most powerful tool we have as developers is automation. I really love this by Scott Hanselman because it really helps us to save time. Next slide, please. And references. So I'd like to properly credit the references where I got all of my materials and some information I'd like to add on aside from my professional experience. Again, thank you for inviting me, and that would end my presentation. I hope everyone would have a copy. I can convert it to PDF and send it through chat as well. Thank you.
Thank you, Kelly, for the wonderful session. And I hope you guys have learned something. If you guys have any questions, you can ask. I think there were a question before during the session.
I'll just we'll wait for your
I think I just pinged again. If you can check the chat box.
oh sorry. I'll check the chat box. Okay. Okay. Oh, what is this question? One question: if I have Linux knowledge but non-experience in programming, can we be DevOps engineer in which major? Actually, yes, you can be a DevOps engineer. You know, there are a lot of companies that offers boot camps so that you would learn a programming language while you're already working. But I do suggest there's a lot of companies who happen to have a junior position. This is where they train employees to have a background, not just with Linux, but also with programming. But you can actually at least suggested to learn it at least a few months aside from Linux, at least just the fundamentals. You can learn the fundamentals. Even if you don't have experience in programming, you can be a DevOps engineer, but at least you know the fundamentals of it. And at least like little by little, step by step, you can create your small projects with it. So at least you know how would variable works, how string, what are the strings and characters, all those stuff. It's good already. So that would be my stand on that. This is the presentation, guys. I just pasted it, so you can access it in view only access. Develop a cross-platform mobile application. I haven't yet, James. I haven't yet developed, but by developing some back-end applications before, I do use JavaScript, Python, and for framework, Flask, Node.js. That's what I've used, but I haven't used mobile application so before. So that's what I can recommend. This is what I've developed before backend applications for login authentication. So that's what I can share based on my experience and branch locator. So those are the languages I've used and the framework. Next is for Max, can a fresh grad be a DevOps engineer, or can you suggest first landing position as a fresh grad in the process to become DevOps engineer? Yes, there are some. Well, for me, from my experience, um, I think some companies require an experience before getting into DevOps. So they require experience, may it be you're a data scientist before or a data engineer before. Because I myself, I've been a data scientist and data engineer before, so I've had a lot of experience with some kind of aspects. But what I can suggest is you can be at least a junior software engineer or associate software engineer, because that's most of the people I know have come to that background and then step up into DevOps. So if you've had those experiences as associate software engineer, junior software engineering, it would be a really good stepping stone to becoming a DevOps engineer, uh, to major it more. So that would be my answer to that. Any questions, guys? Okay, for Janus Sam, okay, the DevOps engineer is it necessary to learn to code? Yes. So from my daily experience as a DevOps, I do use Python. It's easy for me to solve different problems in troubleshooting when you have at least an experience in coding and the development side, because it will require a lot of knowledge from it for you to be able to solve a specific problem. So it is necessary to learn to code. Back end side, Python, JavaScript, because you're going to develop a lot, and for you to understand as well the structure when you create a Docker file or such, or Dockerize a certain server or application. Okay, for Liu Adrian, from Liu Adrian, can I also use Azure DevOps? Okay, yes, you can use Azure DevOps. I've used it when I was a data engineer, but usually in part of the DevOps team, they've used it a lot. But in my current, I haven't used it. Because guys, just to add, there are and on-premise servers and cloud. So there are companies that their servers are on-premise, meaning they have physical servers. They haven't like get into cloud like Azure, AWS, or GCP. So most of the servers usually it's not yet like attached to a cloud, so it's called on-premise. So with its cloud, usually you have at least you're using GCP, AWS, or Azure. So sometimes some juniors are mistakenly like, okay, am I in an on-premise or so? Just like to ask, can someone who doesn't have any computer degree how to become a software engineer based on... Okay, from Asiraf Zaid. Yes. Um, someone who doesn't have any computer degree can become a software engineer by self-learning. Yes, you can. So there's a lot of companies, startups who actually get a lot of people who are skilled who doesn't have a CS degree or an engineering degree or any degree, college degree. As long as you are skilled and you can do all the work within DevOps, software engineering, agile practices, etc. From Suraj Suresh. Okay, sorry, I thought it was a question. Okay. Sandesh, from Sandesh, so only software developer can be a DevOps engineer, or is it relevant? Is it relevant from okay, just to make clear, guys, that is one of my recommendations to get at least into associate software engineer, because most of the people I knew, they came from that background. That is where I based that answer. But just to be clear, not only software developers can be a DevOps engineer. May it be in any background within IT industry. I came from data science background. I usually do math and statistics, machine learning models and such, and I became DevOps engineer. So it's relevant. Yes, it's relevant for network security engineer, cybersecurity, business analyst. It's relevant as long as you can understand the fundamentals and you have at least experience like in coding and working with team who are having code collaboration. It's good. So just to make clear on that part. Any questions, guys?
I think that's it from the question side.
Oh, okay.
Yeah. Thank you again for Nick Kelly for the session, and I think attendees have had a great session on the DevOps, and I think they know how to go on forward with the after the session. So thank you again, and thank you all for joining the session. And I have shared some link to the DevOps where you can get started with the in Microsoft Learn itself. It's from, and if you want it in email, you can just fill out the form which it comes up when you click on those both links. So if you want that resources, that I think, yeah. So yeah, you will get that resources there. So yeah,
Okay.
and yeah, thank you. And we are winding off for today.
All right. Thank you so much again, guys. Okay. So I'll be saying goodbye to all of you and thank you again for inviting me since I'll be jumping into another tech session as well. Thank you.
Thank you.